Here is graphically. Graphically, you look at the graph, it looks like this, right? Sort of. Okay, something like that. If you look at the graph, you can kind of see the function is, remember, if you imagine a point moving along here, that thing is, the function is decreasing to there and increasing past there. Right? Okay? So what you could say graphically is you could say it is increasing for, sorry, not increasing, I put it on the wrong side. It is decreasing for x less than 0. It is increasing for x greater than 0, right? There's two parts here. It's increasing there. It's decreasing there. You can figure it out analytically by looking at the derivative. Okay? This is the connection that you need to make in here. If you look at the derivative, if f of x, or I guess we should call it y, if y is x squared, y prime is equal to 2x. What you need to look at is for critical points. Critical points are the dividing lines here, right? This dividing line is a critical point. Critical point at 0. Okay? So if you want to find the places where it's increasing and decreasing, what you should do is find where the derivative is 0 or undefined. So you can say 2x equals 0, or this is the one you're going to forget about because it's very infrequently that the thing is undefined unless it's a really weird function, but it's never undefined, it's always defined. 2x equals 0, x equals 0. That tells you the critical points. And then you look in between there for what's happening. So this is where I kind of jumped ahead, I guess, to the number line last time. You can say at 0 is a critical point, and then if you have the picture, you can see what's happening, and you know it's decreasing here, and it's increasing here. It's decreasing for x less than 0, increasing for x greater than 0. Let's say you didn't have the graph, you didn't have this at all. How could you determine what's happening in each of those intervals? You could, without graphing, let's say. But think of the derivative. Or pick a point in here and test it by just checking the derivative. If you want to know what's happening here, just test in this interval what's happening here. Test a point. If you want to know what's happening in the interval that's on this side of 0, just test a point, like something that's easy. What's an easy point to test there? Test, okay, well, whatever. 2 times 1 is 2. It's positive. Remember what the derivative being positive, that means the function is increasing. Okay? F prime is greater than 0, therefore increasing. Okay? That's on that side. Over here, test a point that's on that side, such as negative 1,027,000. 2 times negative 1, negative 2, negative. Therefore, it's decreasing. If you would like to organize yourself with a table, that is a popular method that it seems like everybody gravitates towards.
Whoa. How would a Venn diagram? Does that work?
Probably not. I don't even know how many. What do I need here? I probably don't even need all those things.
Yeah, whose flag are you making?
Not making any flag. I'm making a very sophisticated table here. I am saying this is x. Whoops, I needed one more thing. X. This is f prime. This is f. This is dividing this up. The critical point was at 0. This is for x less than 0. This is for x greater than 0. It's basically the same thing as a number line. F prime of x we found was 0 at 0, right? at this point, when x is less than 0, f prime was negative, right? You can test a point. Here it is positive. If you're really lazy, you can put a sign instead. Since the derivative is negative in that interval, what has to be true in here? What do we know about f? It is decreasing. Since this is positive in there, this has to be increasing. It doesn't matter how you present this. Here it's neither one. It's not increasing or decreasing, right? Well, yeah, it's not increasing or decreasing. You know, I don't want you to put 0. It's not.
That's a negative sign.
I'm not telling you about the values. I'm not telling you about what the actual values are. I'm telling you about whether they're increasing or decreasing. NA, sure, something like that. Can you do the same thing for this function right now, please? Oh yeah, incidentally, what if we looked at the second derivative here? This is special bonus features to this.
How would you do that?
Like those expensive DVDs, bonus features. This is bonus material. You can't just get this on the regular. You see it in theaters, you don't get this. You have to buy the DVD. That's right.
Do you have a DVD that we can buy?
Would you like me to make one?
Yes, that'd be very handy.
That'll be all those hours for
And you put
the
these kind of things, and you put all your YouTube videos on the DVD for us. And you put a little bit of extra stuff.
bonus material, eh? Outtakes?
And it would be, and on the back, like, you really took it to the limit.
We could play that the Eagle song, eh?
Or you could do the chainsaw.
I really. You learned about concave and convex lenses, right? Probably that's where you first learned that in science. Convex is when the thing turns out like that. This is the convex side of the lens because you're on the outside of the curve. Here, this is the inside of the curve, right? Like a cave. If you draw a curve like that, if you draw a parabola, it divides this into two places, right? Outside and inside. The inside of the thing is the concave side. So in calculus we never talk about which way the curve is convex. For some reason they always talk about where it is concave. So they say this is concave down and this is concave up. Even if it does this, which way is that concave? Up, right? Which way is this concave? Down. And we can do the other two corresponding things. That is concave up. This is concave down. What's this? Up. See you fine. I'll fix you. What's that?
Up a little bit.
No, it's not. What's this?
Up a little bit.
It's nothing. You're right. It's neutral.
It's just fine.
Hang on. I don't know why I paused it when you had an actual question. What if it's like this? It's not. Hang on. What? Then it's not even a function, so you can't talk about it, right?
Oh no, I took this off.
Sideways speed.